Good morning, good afternoon, good evening to you all. Welcome to MTH 106 class. That is Mathematics for Management Sciences 2. In this lesson, the course is divided to four modules. Module 1, Module 2, Module 3, Module 4. And each of the modules is divided to 4 units, except for module 2, which is subdivided to 3 units. So the first in the module, which is module 1, we have unit 1, and unit 1 is titled Sets and Subsets. In this, we will be discussing about set theory, which is a foundation to all mathematical concepts. Almost all mathematical concepts, you talk about sets. Even those in medicine, talk of in business, talk of set of your customer, set of clients, set of workers, set of equipments and all that. So that is why it's very useful. It's foundational to all that we'll be discussing. So, what is sets? That will be the first thing we'll be discussing here. So, sets. This is what we are expected to know at the end of this lesson. If you're able to tell me what a set is and identify sets, and also make use of set notation and solve problems involving sets. So, what is a set? A set is a collection of well-defined objects. That is why, if I give you I tell you a specific characteristics of a particular set of objects, you're able to differentiate it from every other. Take for example the set of MTH 106 students in National Open University of Nigeria. You should know that maybe for 2025-2026 section, you cannot mix it with any other person. They are very distinct. A set of human beings on earth, very distinct. Set of electronic gadgets in a particular room. All these things are very distinct. Okay, look at the example. We have the capital city of African countries. They are very unique. You cannot mix it with any other thing. You'll be talking of Abuja and all the rest. A set of natural numbers. Look at that. Okay. How do you denote sets? Sets. The set is denoted by capital letter of alphabets. A, B, C, capital letter of such thing. So why the element of a set can be denoted by, it depends on, if you are using alphabet, it has to be small letter. And also, you can list the elements. So, for example, we have set A, and the elements of set A are what? 1, 3, 7, 10. That is by listing. And we just say set A is a set of natural number. That means we are talking of 1, 2, 3, 4, 5, and so on. Set of natural numbers. I will just describe it. We have what we call set builder notation. Take note of what we have here. We have curly bracket. When you are defining set, it has to be inside a curly bracket, not square bracket, not round bracket. It has to be a curly bracket. Look at how I define in this example way. Look at the way I define my set A equals curly bracket 1, 3, 7, 10. It's different from in bracket that I have in front listing method. You know that one is not a set. I'm just telling you about that method. So that is how you write a set. So we have what we call set builder notation. Set builder form. Look at this one. Set A, I can say set A is X, such that X is one of the first 5 letters in the alphabet. This one is very distinct. Set A equal to X. Any X that is one of the first 5 letters in the alphabet. You can list them. What are those sets now? A, B, C, D, E. So those are the set A now for set builder form. So let's talk about type of. You have finite set, specific number of elements. You have specific number of elements. Like all the example I gave have specific number of elements. Whenever I say set of trees in the whole universe, I cannot mention all the set of trees in the whole universe. I may not be able to mention all of them. Or you don't know the end. Look at the example. Look at example n. Finite numbers. Example m. M means what? Days of the week. The set m, which is days of the week. I can mention all of them: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So that is a finite. We have the number, specific number of elements. But infinite, counting never ends. Counting never ends. So you don't know the end. Look at this example. N is a set of 0, 2, 4, 6, 8, and so on. And so on is go to infinity. Counting never ends. So that is it. So equality of sets. When do we say two sets are equal? Two sets are said to be equal if they have the same elements. What you have, the content, the members of set A is also a member of set B. It doesn't matter if set A is 1, 2, 3 and set B is 3, 2, 1. It doesn't matter the order, but just if the elements are the same. That means we have same number of elements, and each of them they are the same. So we also have what we call empty set. Empty set is a set that contains no elements. And when you are writing it, don't write curly bracket and put dot inside. If you put dot may be an element. So we have the symbol there. I said the example, people older than 200 years, or let's people older than 2,000 years. Do you have anybody on earth that is more than 2,000 years old? No. So that will give us empty set. Also, let's talk about subsets. What is a subset? Now, subsets, supposing we are discussing let's consider all students in National Open University. Our set is what? Set of all students in National Open University. Out of those one are you, that is the student MTH 106 student of 2025-2026. So that means you are subset. This universal set is the whole student of National Open University, while subset is part of those larger population. So the symbol is as this: symbol A contained in B. That is, B means the set student in National Open University, while A means student of MTH 106 class. That's a student of 106 class, a subset of the whole population of National Open University. And you can also see every set is a subset of its set itself. And null set, that is empty set, is a subset of every set. We have what we call proper subset. That is the symbol here. So universal set, as I've said, contains all elements under consideration, everything under consideration. Let's say we are considering students of MTH 106 in National Open University. We have students that study MTH 102, students that study MTH 101. All of them put together, they are students of National Open University of Nigeria. So the universal set we are considering is what? National Open University of Nigeria. All the students in National Open University of Nigeria. So Let's talk about disjoint sets. When we say two sets are disjoints, two sets are disjoint if they have no element in common. Let's say set of animals and set of human beings. What will be the intersection? Nothing. Set of electronics and set of human beings. What is common to the two of them? Nothing. So example, positive numbers and negative numbers, they have nothing in common, they are disjoint sets. That's what we call disjoint sets. Okay, we talked about power sets. Set of all subset of a set. Our notation is 2 raised to power s, not 2s, 2 raised to power s. Why s? The number of elements. That is, if I have, like, look at this example. I have set M, which contains how many elements? 2 elements, A and B. So my power set will now be 2 raised to power M, where M is the number of elements in that set. So that will be 2 raised to power 2. So power set will be have to be 4 now. You remember I told you that every set is a subset of its set. So AB, the set M itself is a subset, while also A is a subset, B is a subset, and empty set, I've said earlier, is also member of every, is a subset of every set. So power set is a set of what subset of a particular set. And how do you know the number of subsets? Is 2 raised to power the number of elements in that set. Hope that is clear. Venn diagram.